Okay, so some of the things we looked at in the last couple of classes. Last class we looked at variation, which is a pretty deep topic, very useful topic. But if we go back a couple of classes, we were looking at equations of this form. Y equals 2/3 x minus 3. And we said that equation had two parts to it. The first part was our starting point, or our y-intercept. The -3 meant we went down 3 and we started there. The number that multiplies the x was the slope, and that's a rise over a run. So that 2 means from this starting point we go up 2, and the 3 means from there we go over, or we run 3, and we get our line. Because of that, we can look at a graph, and we can write the equation from it. Yes, sir.
I just have a real quick question about the testing direction function.
Yeah.
How does it work and where do we get back?
Okay. Yeah, I just sent your tests back this morning, so your scores should all be posted. If you want to redo the questions you got wrong on the test, just redo them, show your work, and then give them back to your contact person there, and they'll scan them in and send them back to me again, and you can get up to half your points back. There were a couple of tests that the scores were a little bit low on. So what I'll probably do is I think will after we get through this unit, after we take the test on Friday, I'll spend a little time on Monday talking about this test a little bit too. And I might actually post another version of the test out there for you to retake and get back some additional points, as well as just half your points for correcting the other one too.
Okay, so as far as corrections go for this one, we should just make time for Monday.
Well, you can go ahead and work on it if you want to, see if you can figure them out. But on Monday, we'll make sure we go over it a little bit more to make sure you know how to do all of them. So if there are any that you're fuzzy on, make a note by them, so we'll go over those on Monday too.
All right, thank you.
You bet. My biggest thing is I just didn't want to stall out in the middle of this unit to go back and go over the test questions yet.
And then for learning the new unit from last week, we're just taking the exam is Friday.
Yep, the test will be Friday. The next class will be the test on this graphing stuff from the last 2 weeks.
All right, thank you.
You bet. Okay, so when we look at this, remember our equation is going to be of the form y equals something times x, and then plus or minus that y-intercept. The y-intercept is easy to find here. It's +4, so that's a +4. The slope is a little bit trickier. We have to find 2 points on the line that we have coordinates for, like that. And I can either draw in the rise and the run triangle. Here, this is going down 4, so that's a -4, and running 3. That's a -4/3 slope. Or we could actually just take the coordinates. This is 0, 4, and this is 3, 0. And we could find the slope from those coordinates. Remember, if I label this point 1 and point 2, that slope is y2 minus y1 over x2 minus x1. So that would be 0 minus 4 over 3 minus 0, or -4 over 3. So we get the same slope either way. These are things that we're pretty familiar with. Today I want to look at writing this equation from the graph, or from some examples on the graph that are not quite that simple, and then from other information that might be given as well. So for this one, let's say I am given this line right here. So again, it's a line, so we know the equation is going to be y equals mx plus b. So we need to find m and b. We can find b, the y-intercept, really quickly here, because the graph here goes to the y-axis at a +3. The slope, again, we find 2 points that are on the line that we have coordinates for. We have this one and this one. And again, I could draw in the triangle that has a rise of 2 and a run of 3. So that'd be 2/3 slope. Or we could have done the points. This one here is 0, 3. This one here is 3, 5. And we could do the slope formula. So y2 minus y1 would be 5 minus 3. x2 minus x1 would be 3 minus 0. Gives us 2 over 3. So that graph gives us an equation, or comes from an equation, y equals 2/3 x plus 3. So now let's take a look at what we can do if we don't have that graph, if we don't have that picture in front of us. So what if we were told that a line has a slope of 1/2 and y-intercept of a -3? Well, that's almost too easy, isn't it? Y equals mx plus b. Well, we can just replace the slope, the m, with 1/2. So 1/2 x. And the y-intercept, the b, with -3. So instead of plus, we're going to put in -3. It's -3. So that isn't really much of a challenge. So we're not going to look at any other examples of that. Let's look at something that requires a little bit more work on our part. So a line has a slope of a -1/4 and goes through the point 8, 5. So let's find that equation. So we're looking at y equals mx plus b. So now in this case, we do know the slope. We know m. So y equals -1/4. Goes in for m. So -1/4 x plus, we still don't know b. We looked at this a little bit last week. To find b, we know, however, that this has to go through the point 8, 5. So that point has to make this equation true. So the 8 actually goes in for x, and the 5 would go in for y. That's xy. Now we have every piece of information in that equation except for the b. So we can go ahead and solve for b. First, I would do -1/4 times 8, which is -2. So I have 5 equals -2 plus b. And then we can solve for b by adding 2. +2 cancels out the -2. 5 plus 2 is 7. So that gives us that b equals 7. So I can bring that back up here to my original equation here. Y equals -1/4 x. Instead of plus b, we're going to put in plus 7. So that is the equation for a line with a slope of -1/4 and goes through 8, 5. So how about, we're just going to assume it's a line. I'm not going to write that it's a line every time just to save some pen strokes here. So it goes through um, 2, 11 with a slope of 3. So again, y equals mx plus b. We know the slope. We know m is 3. So y equals 3x plus b. And again, we can find b because we know it has to go through the point 211. So 211 has to make this equation true. So the 11 goes in for the y. The 2 goes in for x. So 3 times 2 plus b. Simplifying here, 3 times 2 is 6. And then to solve for b, we'll have to subtract the 6. So 5 equals b. So back to this equation, y equals 3x plus b. We now know that b is 5. So 3x plus 5. So if we're given that information, as long as we're given the slope, it's just a matter of putting in the point and solving to find out what the y-intercept is. So the next level of complexity would be to do something like this. To say that all we're going to tell you is that this line goes through the points 3, 1, and 9, 13. Now looking at this, it doesn't look like we have the same information we did before, but really this is the exact same information that we had before. We can find the slope by using our slope formula. If I call this points 1 and 2, y2 is 13 minus y1 is 1, over x2 would be 9 minus x1 is 3. So 13 minus 1 is 12. 9 minus 3 is 6. So that gives us a slope of 2. So now we can go back to our generic equation, y equals mx plus b. We know that m equals 2. So y equals 2x plus b. Now at this point we're exactly to where we were with the other problems. We have the slope, we need to find b. The difference is we have a choice of 2 different points we can use to find b. I can either use the 3, 1 or the 9, 13. They better both give me the same b. In fact, I could actually use one to find b and the other one to double check it if I wanted to. So let's use the 3, 1 first to find b. So the 1 goes in for y, and the 3 goes in for x. So now I can do 2 times 3 is 6. So 1 equals 6 plus b. Solving, all I have to do is subtract 6. So I get a negative 5 equals b. So if I put that back into my original equation here, y equals 2x. b is negative 5. So instead of plus a negative 5, I'm just going to put in minus 5. So y equals 2x minus 5 should be our equation. Since we have the information, let's use the other point to double check that. 9, 13. So the 13 would be y. X then is the 9. So 13 doesn't change. 2 times 9 is 18. So we have the 18 minus 5 is 13. So that does work out to be true. We get the same value on each side. So let's do another example of that. Let's say that we are told that we have a line that goes through the points, let's say 4, negative 1, and 12. What do I want to do here? 12, 3. Let's see what happens there. So again, the first thing we have to do is we have to find our slope to get us back to where we were before. Our slope, we'll call this point 1 and point 2 again. It's y1 minus, or y2 minus y1. y2 is the 3 minus y1 is a negative 1. I put it in parentheses so we keep the negative and the minus separate. Then it's x2, which is 12, minus the x1, which is 4. 3 minus a negative 1 is 4. 12 minus 4 is 8. 4 over 8 is 1/2. So we have a slope of 1/2. Back to our generic equation, y equals mx plus b. We now know that m, the slope, is 1/2. So y equals 1/2 x plus b. And again, we can pick either point to figure out what b is. I'm going to pick the 12, 3 just because I try to avoid working with negatives when I can. So 12, 3 is what I'm going to use. The 12 goes in for the x, 3 goes in for y. So 3 equals 1/2, putting 12 in for x times 12 plus b. So I'm going to combine here. 1/2 times 12 is 6. I have to get b by itself, so I will subtract the 6. Gives me negative 3 equals b. So I'm going to use that with my original equation. Y equals 1/2 x. B is negative 3, so instead of plus, I'm going to put minus 3 for negative 3. I could use the other point to double check that, but I'm going to trust you guys know how to do it. We don't really need to look at it. So that's one of the things we can do to find an equation given certain pieces of information about the line. So we use that slope formula a lot, so that we know that slope, which we use the symbol m for, is equal to y2 minus y1 over x2 minus x1. Well, there are other things we can learn about our lines, or our line segments or pieces of our line, using other formulas. For example, let's say I have the point here of 2, 3, and another point over here, we're going to call this 8, 6. We could find the slope of the line that goes through those 2 points. Now you'll notice I just drew an aligned segment because that's all I want to learn about right now is the segment. We could find the slope using our formula. We called this point 1 and point 2. That slope would be 6 minus 3 over 8 minus 2. 6 minus 3 is 3, 8 minus 2 is 6, so that's a 1/2. Other things we might want to know. The length of that line. Or sometimes discussed as the distance between the 2 endpoints of the line. What we found for the slope, the y2 minus y1, the rise is that length right there. The run, the x2 minus x1, is that length right there. Now, if we look at that, we see that that makes up the 2 legs of a right triangle. And the length of this segment, or the distance between the points, is the hypotenuse of that right triangle. When we have the formula, a squared plus b squared equals c squared, is the length that defines the length of the hypotenuse. Many of you may have seen that formula rearranged just a little bit, with the c up front, and instead of c squared, it's the square root of a squared plus b squared. And that's the form we're going to work with here. Our distance, or our length, we should use d for distance, is equal to the square root of, we're going to let a be this leg here. And that was x squared, or x2 minus x1. And that, of course, that length would be squared. Plus, we're going to let b be this leg over here, which is y2 minus y1 squared. So the distance between those 2 points, I'm going to fill it in over here. x2 is 8 minus x1 is 2. That'll be squared. Plus, y2 is 6 minus y1 is 3, and that'll be squared. So 8 minus 2 is 6. That'll be squared. 6 minus 3 is 3. 6 squared is 36. 3 squared is 9. So this is going to be is the square root of 45, or 6.708. So the distance between those 2 points is 6.708 units, depending on what the units were in our coordinate grid. So I don't have to be given the graph, I just have to be given the points. Find the distance between the points -3, 8 and 2, -4. So let's give this a shot. That distance will be the square root of. So again, I have to label them points 1 and 2 just to keep them straight. So x2 would be 2 minus x1 is a -3. That'll be squared. Plus y2 is the -4 minus y1 is 8, and that's going to be squared. So we have to be very careful with our negatives here. 2 minus a -3, remember minus a -3 becomes plus a positive, so that'll be 5. -4 minus 8 becomes -4 plus a -8, which will be a -12. Now we'll square each of those. 5 squared is 25. This is again where you have to be careful with your calculator, because when you square a negative, if you don't enter it correctly, it'll try to give you a negative result. You have to put the parentheses around the -12 to square it, which will give you a positive 144. Anything squared, as you recall, is always positive. Now we just add those together. 25 plus 144 is 169. And we take the square root, which will be 13. So the distance between those 2 points is 13 units. Another thing that it might be nice to know about our segment, what I have here, 2, 3, and 8, 6, is there are times when it'd be nice to know where the halfway point is, or where the middle is. That is called the midpoint. And because it is linear, the midpoint's actually pretty simple to find. I'm going to draw my triangle back in here for my slope. This midpoint, or middle of the line segment, if I trace it over, it's going to be exactly halfway up my rise. If I trace it up, it's going to be exactly halfway across my run. It'll be in the midpoint. Now, if I am on a number line, and I'm just going to look at x here for right now. So if this is 0, 1, 2, 7, 8. So I have a point here at 2, that's my x-coordinate, and a point here at 8, that's my other x-coordinate. If I want to find the midpoint of those, right in the middle, what I'm doing is taking the average. 2 plus 8, and then divide that by 2. 2 plus 8 is 10, divided by 2 would be 5. The midpoint would be right here at 5. And you can see graphically that does turn out to be in the middle. So that tells us that the x-coordinate of that midpoint would be 5. It's between the average of the x-coordinates of the endpoints. Same would be true for that y-coordinate. So we have 3 and 6. 3 plus 6 over 2. 3 plus 6 is 9. Divided by 2 would be 4.5. So 4.5 or 4.5 is the y-coordinate of that midpoint. So if I have, let's just say find the midpoint. Of the segment connecting -5, 12, and 3, -2. So again, I'm just finding the average of the coordinates. My midpoint is independent of in each direction. So I can find the midpoint for the x direction and the midpoint for the y direction. So to find my midpoint, I'm going to do this. This is going to be my coordinate for my midpoint down here. For x, I'm going to average together the x coordinates. So -5 plus 3, those are my two x coordinates, divided by 2. -5 plus 3 is -2, divided by 2 is a -1. So my x coordinate is a -1. For my y-coordinate, I have 12 and negative 2 are my y-coordinates of my endpoint. So 12 plus negative 2 divided by 2. 12 plus negative 2 is a 10. Divided by 2 is 5. So negative 1, 5 is the midpoint of that. Okay, so what are some other things we can do with our lines? Parallel lines. We've seen this in our graph before when we started exploring our lines. If I have a line here, let's see, this one right here. And then I've drawn another line that is parallel to it. Those two lines, as you can see when I drew them, have the same slope. This one rose 2, ran 3. This one must also rise 2 and run 3. If those slopes are different at all, they're going to get closer to each other or further away, depending on what direction you go, over the distance. They have to have exactly the same slope in order to stay equidistant, or the same distance apart. Remember, we defined parallel lines as lines that are always the same distance apart. A little bit stronger than just saying they never intersect. So parallel lines must have the same slope. So if I have a line that has a slope of 2/5, any line that is parallel to that must also have a slope of 2/5. So if I give you y equals a negative 1/3 x plus 7, we know the slope of that line is negative 1/3. The slope of any line parallel to that line must also be negative 1/3. So if I want to find the equation of a line parallel to y equals 3/4 x minus 2, I know by looking at that equation, I know the slope of that line is 3/4, because that's the number multiplying x. So I know the slope of the line parallel to it will also be 3/4. But I need to know more. I need to know how to find the y-intercept. I could give you the y-intercept, which would be simple. I'm going to say this. Find the equation of a line parallel to y equals 3/4 x minus 2 and through the point 8, 7. So all I need from this equation right here, the only piece of information that matters to me at all, is the slope. And now the slope of my new line, on my parallel line, will be the same. So m will still be 3/4. So y equals 3/4 x plus b. And now we're back to exactly what we were looking at 20 minutes ago. I have the slope, and I have a point that gives me one solution for x and y. Has to make that equation true. So the y would be the 7 equals 3/4 times x would be the 8 plus b. 3/4 times 8 is 6. Solving for b now, I'm going to subtract the 6. I get 1 equals b. So I come back up here to my original form of the equation. This tells me y equals 3/4 x plus b. Well, b is a positive 1. So there is our equation. Your question? Okay. Well, I want to take some time to also then look at perpendicular. So, perpendicular lines of course form a right angle with each other. If we're looking at right triangles, now let's just put a line on here. So I put this line on here as a slope of 2/3. For a line to be perpendicular to it, I'm going to put it through right here. The right angle. First of all, the slope of this line must be negative. So for lines to be perpendicular, one has to be positive and the other has to have a negative slope. Can't both be positive or both be negative. The second thing we'll look at is we see this triangle here is our slope triangle, rise and run, and it forms a right triangle. Well, I want to form a right angle here. So I need to know what would this triangle be here to form the slope of that line, that perpendicular line. Well, if we're looking at right triangles, what angle would I add to this? What angle? The word would be complement to add up to 90. What angle would complement this one? Well, that would be this angle over here. So this slope triangle here, this would be a right angle. This angle has to equal this one. So what it does is we're taking this slope triangle and we are rotating it to fit in here. It's the same triangle. We have just swapped the rise and the run. So the slope of this one is going to be negative, as we said, and we're going to swap the rise and the run. So it'll be 3/2. Now the term we use for that with fractions is reciprocal. You flip the fraction over, making it negative, 1 negative, 1 positive. The term for that is opposite. So perpendicular lines have slopes that are opposite reciprocals. So if I have a line with a slope of -5, the slope of the perpendicular line is going to be the opposite of that. So it's going to be positive. The reciprocal, well, this would be -5/1 to make it a fraction. So it'd be a positive 1/5 is the slope of the perpendicular. So let's say I want to find the line perpendicular to, and by find the line I'm implying give the equation of, perpendicular to y equals 1/3 x plus 2 and through the point 2,5. So again, looking at this equation here, the only piece of information I want from there is the slope. M equals 1/3. For the perpendicular, our slope is going to be the opposite reciprocal. So negative, and then flip it over 3/1. So -3 is the slope of that perpendicular. So back to our generic form, y equals mx plus b. It's going to be y equals -3x plus b. And we will use our point, we're going to use our point here, the 2,5, to find b. Well, y is going to be the 5, equals -3 times x will be the 2, plus b. So now we're going to solve. -3 times 2 is -6, plus B. Adding 6, get rid of the negative 6. So 11 equals B. And we can put that back into our original form of the equation. Y equals negative 3x. And instead of plus B, it's a positive 11. So plus 11 is our equation. All right, so I realized we went through a lot of things in this today. All of these are things you need for relating equations to other things. In engineering, it happens a lot. If there's a shift in the starting point or whatever, what is your new equation? In many cases, it's a matter of changing the y-intercept, and you know the y-intercept. But there are applications in the medical fields where the whole idea of giving you the same point or different point is very applicable. For example, we have two IVs with the same flow rate. Okay. So IV1 at 2 hours contained 1,200 milliliters, and at 6 hours contained 1,000 milliliters. IV2 at the 2 hour point contained 600 milliliters. Assuming both have the same flow rate, as we stated up ahead, and both started at the same time. How long has IV2 been flowing? So we're making the assumption that this 2 hour point is the 2 hours from IV1. So we know the start time for IV1, and this is 2 hours after the start time for that first IV. This is 2 hours after the start time for the first IV, but we do not know the start time for that second IV. So we're going to work on finding the equation for this first IV. We know it goes to the points 2, 1,200, and 6, 1,000. Shiramagan, looks like you guys are heading out. There are worksheets posted on Blackboard for you to work on for these topics. So anyway, let's find the slope, and then we'll do the y-intercept. So our slope first, points 1 and 2. So y2 is 1,000 minus y1 is 1,200 over x2 is 6 minus x1 is 2. This is a negative 200 over 4 is a negative 50. That is our slope. So that gives us y equals negative 50 times x plus b. Well, we know that y is 1,200 here when x is 2. So 1,200 equals 100 plus b. Or negative 100, I should say, plus b. So we're going to add 100. So this started out with 1,300 milliliters in this IV. That's b. So the equation for that IV is y equals negative 50x plus 1,300. Now that doesn't tell us what time it started. At what time would there be 1,300 milliliters in this? Well, we'll put 1,300 in. Well, I guess we know what time it started. We know it's at 2 hours. But we now know that it started out with 1,300 milliliters. So now we need to go back and figure out, using that idea of 1,300 milliliters, to figure out what time this IV started. So we know that that IV has the same flow rate, so it'd be the same slope, negative 50 times x. And they started with this at the same time. I didn't mean to say started at the same time, did I? Sorry, they both started at the same volume is what I meant to say there. So they both started with the same volume. IV1 started with 1,300 milliliters. We're going to assume that IV2 also had 1,300 milliliters. So plus 1,300 here. How long has it been flowing to get down to 600 milliliters? So 600 goes in for y, and we can solve for x. Subtracting the 1,300 gives us negative 700 equals negative 50x, and we can divide by the negative 50. Which gives us that x is 14. So at the 2-hour point when we checked it, this bag had been flowing for 14 hours already. So this one had been flowing for 2, this had been flowing for 14. This one was started 12 hours before this one. I got a little bit jumbled there because I messed up my question a little bit. Sorry about that. But you guys get the point of how it can be applied. So anyway, there are 3 worksheets posted on Blackboard. If you look at the bottom of the recordings and the course information, they're there. Feel free to work on those if you want to. Well, if you want to. Some of this will be on the test, like the slopes and midpoints and distance will be on the test. I'm not going to have you get too far into this last example or anything like that. There is one thing in the worksheets we did not talk about, graphing quadratics, so you can ignore that part of the worksheets if you want to. That was an optional part of the course that we just didn't get to. But, with that, remember your test will be on Friday. So you guys have a great day, and I'll probably send the test out right now in case there are any of you that have to make other arrangements to take the test.